Live. Okay. So we are continuing our discussion from yesterday, which was factoring simple quadratic trinomials. Yes, right? So that's we're just gonna keep going. There's a few more ways that these might kind of manifest, and that you've got to know how to, solve them, how to factor them. But it's the same process. That's the cool part. It's exactly the same process on all of them, with the exception of differences. Okay, so we got, let's say we had x squared plus 6x plus 8. How would I do this? That's a simple quadratic, right? So I'm going to put my parentheses right away, because I know I'm going to try to factor it. So Ben, help me.
Okay, so
Factors of
8.
8, which are
4 and 2.
4 times 2 is 8.
So
All right.
it would be x
4 plus 2 is 6, so it would be x
2.
plus 4, and then x plus 2, right?
That probably sounded like gibberish.
Now, and I explained outside and inside with my fingers, right? This is the one class it's okay to use your fingers, right? So it's 2x plus 4x is 6x. It works, right?
6x.
Right? 2x plus 4x equals 6x. So I suggest every time you factor something that you get in the habit of doing it, just to be sure you got it right, right? Now, if you do this method though, just so you know, and you don't leave until you're sure that equals that, this plus this equals this, then you won't make a mistake. But if you don't use that method, then definitely you're going to want to check. But checking is always a good idea, right? So, okay, so that's our number one problem. Okay, so let's try a different problem. Let's say I try, let me grab,
using the
right.
textbook?
x squared minus, okay, how about this one? X squared, I forgot it already. Where was I? Oh, yeah.
How could you forget?
Okay, here we go. All right, so
That's me, I'm sorry.
Michael, help me. Michael, help me.
I'm sorry.
So you would
Factors of
14,
that add to
2 and 7.
2 and 7. What?
So
What?
9 and 11.
Oh, shoot. Oh, my gosh.
No good.
Do you use division?
What?
Use a negative
Math
number.
doesn't work.
Minus. Do a minus.
Dude, use a negative number.
What?
Good wrong.
What about x minus 2 and x minus 7?
Yeah, that's what I'm saying.
Does
Use
that
a
work?
negative number. Just add it to a negative
Yeah,
number.
just
Wait.
say it's minus.
Add
So,
a negative
yeah,
number,
you're-
bro.
Wait. I just want to clarify. You're saying that if both of the factors are negative, then the product is positive.
Yeah.
Negative 2 times negative 7 is positive 14. Oh my God, you guys saved math. This is amazing.
We
So,
saved myth.
Michael, what do I do?
You think about it, say that.
So x
No, I didn't.
minus 2 and then
Oh.
x minus 7.
Fabulous.
LG.
Double check. Negative 7x minus 2x minus 9x. Boom. Right? It worked.
It's instant.
All right, let's try another one. Let's try 3. God, I don't know why I can't remember these. X squared minus 17x plus 72. I think it was. All right, Tia, help me with this one.
I don't think that's how cooking works.
So factors of what? Factors of 72 that add to what? Negative 17. All right, so
3.
72, factors of 72. How about 9? 9 times what? I can't hear you. 8, yes. 9 times 8. Let's see. What is 9 plus 8? 17. Oh, we need it to be negative.
Subtract it.
So both of them are negative. That would still give me a positive 72 and a negative 17. So my final answer is x minus 9 times x minus 8. Good job. Excellent. Fist to 5. Makes sense, right?
5.
So now let's look at what we've learned so far in terms of patterns. Mathematicians, being a mathematician is about seeing patterns, right? Seeing patterns. And do you notice a pattern here? Now look, both of them are positive here in this one, right? Both of the, guys, focus, focus, focus. Please stop. Focus. Both of these are positive, right? Please stop. Stop. Both of these are positive, right? Notice, look, both of these are positive. There's no negatives in this, in the original problem. If there's no negatives, there's no room for negatives in the factoring. Does it make sense?
Can I ask something?
Yes.
What if you were to have a negative, let's say you had an x squared minus 17x minus 72.
Oh, very good question. We're moving there next. But I just want to look at our, the pattern we've noticed. So Lila, what have you noticed for these? I've got a negative 9x plus 14.
There's only one negative.
There's only one negative.
But there's two negatives.
Now, yes, there's two negatives in the answer. Now, ironically, both of these have a pattern that's very similar. You see the pattern that's very similar. Look at this. This last number is positive. This last number is positive. In order to have two numbers multiplied to be a positive number, both of those numbers must be what? The same sign, right? They either have to both be positive or both be negative. So this plus sign tells me that my answer has to have both positives or both negatives. Does that make sense? You see that? Right? This one tells me which one it has to be. If that's positive, they both have to be positive. Boom, boom. This one says both of them are the same sign. This doesn't say they're both positive. It says that both of my factors are going to be the same sign. That's the only way I'll get a positive number, right, when I multiply them. But this sign tells me that they're both going to be negative, right? Does that make sense? Both are negative. Both have to be the same sign. Both are negative. You see that? All right. So now, can I erase?
Yeah.
All right. So it's just helpful to see those patterns.
If it was negative, like minus 72, then would there have to be a positive and a negative?
Ah, very interesting. What?
Or would they both be
I have a
positive?
clue. No, well, we're going to work on that right now. So let me get one that is like that.
We're curious, they're both negatives, and would they both
X squared
be
plus
positives
3x minus 7. Hang on a second. Item number 4, right? Okay, x squared minus, oh dear, where was I?
All there.
3. X squared plus 3x, sorry. Plus 3x minus 70. Is that sort of like somebody, like Ben, you were asking?
No.
If that one is negative.
I was also asking it if.
Oh, if this was also negative? All right, so let's do both of these. So this will be number 5. Okay, so we'll do x squared minus 3x minus 70.
Can we
Same
do
thing,
4
I mean,
first?
same, different problem, right? All right, so here, how do we do it? Factors of negative 70, that negative is important. Factors of negative 70 that add up to 10.
I mean 3.
What do I know? In order for this to be negative 70, what do I know about the two numbers?
You
How about, one has to be a negative, so how about negative 10 and 3, or 7?
All right, so we got negative 10 and 7, or we could have 10 and negative 7, right? But they would have to be, each one would have to be positive, one would have to be negative, right? So now the question is, which one of those would be the answer to this problem?
Well, the bottom one.
Neither,
This
because
one, right?
that's a 3, yeah. 10. Oh, wait.
The bottom one.
What's 10 minus 3?
Oh.
Minus 7.
It's 3.
Ah, so immediately, this is a simple quadratic trinomial.
Okay.
I've got my x and my x, because x times x is equal to x squared. And so the answer to this one would be this one, right?
Yep.
Now, okay, so plus 10 minus 3, excuse me, minus 7.
Number
Right? So this is interesting. Well, let's worry about that, the pattern in a second. Let's go to this one, number 5. I'm looking at,
Would it be the first one? Yeah, it's
now it's going to be the first one. So it'll be x minus 10 times x plus 7. All right. Now, does anybody see a pattern
Yeah.
that is kind of interesting?
Sure.
Pattern.
Just flip.
Michael.
One has to be positive and the other has to be negative.
Okay, that's part of it, totally. Mira? Ah, that's interesting. So yes on Michael and yes on Mira. But if this is a negative, these signs have to be different, right? They have to be different. So yes on Michael. And then what Mira said is if the middle number is positive, the bigger factor, the bigger number has to be also positive. That's the only way it's going to work. If the middle number is negative, the bigger number has to be negative. When I say the bigger number, I know negative 10. I'm just saying like absolute value of 10 and 7, right? 10 is bigger, 7 is littler. If that's negative, 10 has to be negative. The bigger number has to be negative. Does that make sense? You guys see that? All right, awesome. So, okay, let's do one more, and then I'm going to let you, but I'm afraid you'll do the homework too fast, and then it'll be all done, and then it's like, it'll be so sad. Okay, but let's try this one. Okay, m squared, no, we'll do x. X squared minus 7x minus 120. Okay, 6, x squared minus, I forget it already. 7x minus
You are.
120. Okay,
Okay, Gary.
all right.
Yeah, okay, yeah.
Ooh, this one looks hard. Hard.
Is
Oh,
it?
why would a math teacher do this to me?
Because they can.
Because you're the math teacher.
Right. It's our nature. Okay, so what would I do? What do I know? Immediately, I could do this, right? I could draw this. What do I know about my, what do I know is going to be here?
X.
X, right?
And a negative.
Because x times x is definitely equal to x squared. Now what do I know about the signs?
There will be a minus and a plus.
So I'll put a minus and a plus. Okay. Now I've got to do my little thing. I know it's going to be negative 120.
So, why don't you just take out the 0? No. That
can't
would
do that.
completely change it.
Yeah.
work
Yeah.
then.
So this is where a factor tree is useful, right? Sometimes you'll think about it and you'll figure out, oh, I know it's 12 times 10. But no. Let's try that. Let's just try 10 times 12. What would, if one of those was positive and one of them is negative, I would have a difference of what? 2, right? It's got to be negative 7, right? So it's not going to work. That's not going to work. So another way I could do it is I could say, okay, well, let's see. 10 is 2 times 5, and this is, say, 2 times 6, right? Now, I could keep going, but I'm going to try rearranging these numbers. Does that make sense? No, actually, that's not going to work too well either. I'm going to have to keep going. So let's go with the 6, 2, and 3.
Okay.
Because if I took this 2 and multiplied it that times that 5, and this 2 and multiplied that times 6, I would still get.
This is how family
times
tree
12.
works, Gary.
Is this like a pyramid?
So
No,
now,
is this a
so now look. So look. I know that this times this times this times this times this equals that. Do you agree with me? Am I right?
Yeah.
So I can rearrange which ones get multiplied times what. I like the 3. I notice the 2 doesn't seem to work so well for me. So I'm going to, oh, how about, wait a minute. 2 times 2 is 4. 4 times 5 is 20. Let's see, so we got 20 times what?
2.
And that, so I did 2 times is 4, times 5 is 20. And then I've got 2 times 3 is 6. That's not going to work, right?
Gary,
So that
can I
didn't
just
work.
do 120 times, or
So-
7 times?
Let's try 3 times 6, that's 18. Let's try 18. 3 times 6 is 18. 4 times 20, no, that's not gonna work. Wait, is that right?
Why
Oh, yeah, that's right.
off?
What did I just do? 3 times, oh wait, I'm doing 3 times,
2.
what am I doing? I'm not 3
I
times
don't
6,
know. What
sorry.
are you doing?
Sorry,
Gary,
I'm
if
sorry.
you don't know what you're doing, you're the
Yes,
teacher.
I'm sorry. I'm supposed to only look at the circled ones, right? I made a mistake, I looked at the 6, yes.
2 times 2 is 4, 4 times 5 is 20, 20 times 2 is 40, and 40 times 3 is 100. But you're looking.
Right, but we're looking for two numbers that are 7 apart.
Yep, you have to use all of them.
Yeah, you gotta use all of them. So let's try 3 times 2 is 6, right?
Gary, the numbers are gonna work. It's the same multiples each time.
6 times 2 is 12. And then 2 times 5 is 10. Oh, we did that already. 6, okay, how about 3 times 5 is 15. 15 times 2 is,
30.
wait, 15.
Hey,
What's 2 times 2 times 2 is 8.
15 times 8, yeah.
Yes, look at that.
We all got it.
So do you see this process though? Of using your factor tree and then rearranging those numbers until you find something that 15 minus 8 would give me 7. So which one would I have to make negative? The middle number,
8.
I would have to make the larger number
It's
15. So I'm gonna put the 15 here and I'm gonna put
Yeah.
the 8 here, right?
Wait, why didn't you?
So we worked. It worked.
Ooh.
So that
What's the question?
equals negative 7.
Yeah,
I'm
But where are you confused?
you're confused.
Yeah,
Oh,
free
sorry, I
where?
was looking at the wrong problem.
Oh yeah, we're looking at this. Don't look at those. This is the problem we're looking at.
Oh,
You are
Right?
I just like
You get it?
it.
So fist of 5. Did you understand what we did to find? Because every now and then you're going to get harder problems like this, and you're not going to know your 120 times tables. You know, like you're not going to know what goes into 120, you know, or 125, or 127, or 128, or 149, or 264, or you know what I mean? You're not going to know those. So you see how the factor tree is useful, right?
Yes.
Makes sense? Yes.
So why do all of that and then have to rearrange all those when you could just since you know what you have to find, why not just find numbers that add up to that number? Yeah, but wouldn't that be a lot simpler than rearranging all these multiples and trying to find some that are 7
There's a
apart?
lot of numbers that add up to -7. There's like an infinite number of numbers.
Oh.
You know what I'm saying? I mean, it's a good idea. It's a really good idea, and it would work.
We just
And
use a calculator.
that would be your guess and check method. It's a good thought. That is a guess and check method, you know. And yeah, and, you know.
Oh, wait,
But
the
to
lowest
me,
possible?
this was a little harder this time. But you're gonna find. So listen up. You're gonna find that oftentimes you don't have to go all the way, right? Sometimes you'll just go to here, right? You'll just get the 2 layers down, and you'll realize, oh, but if that were a 3, 3 times 6 is 18, and then then suddenly it works, right? But sometimes it doesn't. Sometimes you have to go all the way to get prime numbers on everything. You know what I mean when I say prime numbers, right? Everybody understands prime numbers? Numbers that are divisible by 1 and itself. Like 7 is a prime number. The only way to get 7 is 1 times 7. That's it.
5 or 13.
1,
5 is an example. 13 is an example. 3 is an example. 2 is an example.
1 is an example.
it's not.
No.
1 times 1,
Tec-
and it's only divisible by
Technically,
itself.
1 I don't believe is considered a prime number, and it's because even though you are
71.
right, you are wrong. No,
71 or something.
it's not considered a prime number. 2 is considered the first prime number. Ironically, 2 is the only even prime number.
Yeah, because 2 goes in every other even.
Right, right. Because all even numbers other than 2 is divisible by not only
Well,
1.
Why
Two
is
goes
1
into
not
two,
classified
so
as a
it
prime
is.
number?
Because
It's
one
Because it's 1, it's divisible by 1 and itself, but
Exactly.
itself is 1, therefore that doesn't count because then you're,
One and one.
right.
exactly, so it's
So
still a
zero.
prime number.
Gary,
Are you winning or losing? Are you saying that it is a prime number?
No, certainly not, because if it's divisible by one and itself is 1.
Yeah, but it's
So
still
that's
1.
saying
It's still itself, and it's
let's
still
just-
1.
Okay, I have a
Stop trying
question.
to make
Okay.
sense of math now.
All right, this is a lecture. Oh my God.
I have a question.
We're yes.
So would that make 0 and infinity like an anti-prime number since they can be multiplied by anything and there's no
Anti-prime. That's an interesting thought. Anti-prime. I think so. Let's call it anti-prime.
Yeah.
Yeah, I think I should stop this before somebody.